Already had to put the computer to charge.
All right, so we will wait a couple more minutes just to see if more folks show up, and then we will go ahead and get started. Hi, folks. Thanks for being here. We're just going to wait a couple more minutes still, see if more people show up. All right, we will go ahead and begin. Hi, everyone. Thank you so much for tuning in to this next Universe at Home event. Before we jump into the science that we will be discussing today, we will go ahead with introductions. So my name is Sarah Taft. I am a first-year astrophysics PhD student here at the University of Minnesota, and my presentation partner is...
Hello, guys. I'm Christina Andrade. I am a third-year undergraduate student in physics and astrophysics and a lab instructor here at the university, and I'll be helping Sarah today present our solar system's moons.
Right. So yes, as Christina said, today is going to be all about moons. So we will go ahead and jump in. So in order to talk about moons, we have to define a moon. So what is a moon? And that's actually a lot easier said than done, defining a moon, because there really isn't a concrete scientific consensus for a definition. And this is because the bodies and objects in our solar system are very diverse, they are various, and it is hard, given their diversity, to constrain them to a single definition. So nonetheless, we typically say that moons in our solar system are celestial bodies that make an orbit around a planet. And as I have said, there are lots of different objects that do this. And some of them are really, really tiny. Some of them are really large. Some of them have really deep atmospheres. Some of them have volcanoes. And we're going to be exploring and diving into all of those moons today. So in order to do this, we will start from the innermost part of the solar system, and then we will work our way out to Neptune. And a little fun fact about our solar system is that it has over 200 moons. And that is obviously way more moons than we have time for today. So for the purposes of keeping this talk to a reasonable time limit, we will only be covering some of the bigger ones, the ones that are more interesting in terms of scientific research and potentially for future discoveries. All right, so that said, we will jump into the moons. So starting with the innermost planets, Mercury and Venus, neither one of these planets actually have a moon. This might be a little bit counterintuitive to what you might think. You might think, well, they're a planet. Planets have moons. And of course, we know this from our day-to-day life when we see the moon orbiting our Earth. And while that is true, when you are closer to the sun, things look a little bit different. So we don't know definitively why Mercury and Venus don't have moons, although we do think we have a pretty good scientific hypothesis. And we think that neither of these planets have moons because they're simply too close to the sun. And we know that the sun is absolutely massive, right? I think it's a million Earths in terms of mass can fit into the sun. And that much mass, when it is that sort of compact and in that close range to planets such as Mercury and Venus, can really have some intense gravitational effects. And if the sun has intense gravitational effects on planets like Mercury and Venus, which are large and would be larger than their potential moons, the gravitational effect that the sun would have on those potential moons would be just too aggressive. It would, throw them outside of their theorized orbits. It would rip them to shreds. It would cause them to do all sorts of funky things that basically cause them to be just unstable and not viable. And so that is why we don't really see moons around these two planets. So it's an interesting thought experiment for sure to think about why these planets have moons, or why these planets don't have moons. But that's sort of, we'll leave it at that for now because there's no moons for us to discuss. So moving on out to the next planet in our solar system that we all know very well, that is the Earth. And we do know that the Earth has a moon, as we are all familiar with. We have seen the moon in its various forms and its various phases behind clouds and on clear nights. The Earth has a moon. It is Earth's only moon, so Earth only has one moon. And this is different compared to, a lot of the other planets that exist farther out in our solar system, and we will get to those as the discussion goes on. But a little bit of a background and sort of the origin story about Earth's moon. So there's actually no definitive sort of agreed upon clear-cut formation theory for the moon. The scientific team, I take that back. There is typically an agreed upon formation theory for the moon, but it's not provable. And it's not provable because we don't have a time machine and we can't go back in time to see when the moon itself formed and to see exactly what that process looked like. So our models can be very, very accurate, and we can, imitate what the Earth-Moon system looks like through, computational models and whatnot. But we will never fully be able to say that, yes, this is exactly what happened to form the moon. So nonetheless, all of that aside, the most agreed upon theory of how the moon formed is that back when Earth itself was forming, there was an impact that proto-Earth, it's called, underwent with a Mars-sized celestial body that colloquially is known as Theia. And the story goes that Theia crashed into the proto-Earth, or the forming Earth, and caused a chunk of it to break off, fall into orbit, and that chunk of moon, or of then Earth, is what we see as our moon today. And there are many limitations to these other theories and reasons as to why we think that the Theia hypothesis is the best one. And these have to do with, initial rotation rates of the Earth being too high for some theories, and requiring certain atmospheric extensions for other theories. And if you have more questions about that, we would be happy to answer them later on. But for the sake of time, we will just stick to the theory that we know is true. Oh, yes, and I should say as well, I should have said this at the beginning, but if you have questions, the chat box, the live chat should be open. So feel free to drop them in there as the presentation goes along, and then we will answer them at the end. All right, so continuing with the moon, we know from just looking at the moon in the sky, from looking at the moon through telescopes, from looking at the moon in this image that we see on the screen here, that there are lots of craters on the moon. And these craters are from impacts with, random gravitational masses that just happen to fall into the Earth-Moon orbit. And they strike the moon and create the craters that we see here on the screen. And these craters are often a sort of a temporal map. The more craters that an object has means that object has been exposed to more impacts over a longer amount of time. So typically, and there are some exceptions to this, but typically the more craters an object has, the older it is. And we're able to see this on the moon. We also know that the moon is a very popular site for space exploration, as it is sort of the nearest non-terrestrial astrophysical body that is in our solar system. It's right nearby. I mean, it's still pretty far away, but compared to some other places in the solar system and in the universe, it's very close. And so we have had numerous space exploration missions sent to it. In the Apollo missions, there are some proposed missions in the future, like the Artemis missions. And even though the moon is pretty close and we're able to get great images of it with telescopes, we're able to learn a lot about our solar system and our Earth system and our moon Earth system by exploring the moon. And in a sort of scientific fiction, sci-fi vein, the moon has been sort of theorized as a potential base for future space exploration. So we'll be able to set up like a space station on the dark side of the moon, if you're being a little bit dramatic, and then use that as a base to sort of route missions to farther out in the solar system out of. So you could have a pit stop on the way to Mars, or a pit stop on the way to the Jupiter system or the Saturn system. So our moon is very cool for lots of different ways, and it is our only one that orbits this Earth, so that's kind of cool too. Okay, so we will go ahead and move on out deeper into the solar system, and Christina, excuse me.
So I'll be discussing Mars moons, and Mars has an interesting set of moons. So the moons of Mars are the smallest in the solar system. As well, no known moons orbit as close to its parent planet as Phobos and Deimos do. Now, Phobos orbits only 3,700 miles above the surface and orbits the planet about 3 times a day. So its distance is 3,700 miles, and orbits Mars 3 times a day. Meanwhile, Deimos is 14,576 miles away, and it takes 30 hours to orbit. To compare, Earth is 238,900 miles from its moon. So they're pretty close. And due to the fact that both moons are heavily cratered, lumpy objects, they look like somebody grabbed like those gray erasers and mashed them together. They're believed to be captured asteroids. So because of Phobos being so close to Mars, you know, it's demonstrating an interesting phenomena. So to preface that, Phobos and Deimos are tidally locked. Tidal locking occurs when an orbiting body always has the same face toward the object it's orbiting. So like Earth's moon, Phobos and Deimos are also tidally locked. So Phobos is demonstrating an interesting phenomena. It is losing altitude. It draws closer to Mars 1.8 meters every century. In the next 50 million years, it'll arrive at its Roche limit. Now, in orbital mechanics, the Roche limit is the minimum distance to which a large satellite can approach its primary body, so Phobos to Mars, without tidal forces overcoming the eternal gravity holding the satellite together. So when this happens, when it surpasses its Roche limit, Phobos will either careen into Mars or disintegrate and form a ring around the planet. So exploration of Phobos and Deimos has been proposed, but never really executed. NASA has considered the possibility of using one of the Martian moons as a base from which astronauts could observe the red planet and launch robots to its surface. Now, it's being considered because they will be protected by miles of rock from cosmic rays and solar radiation for nearly 2/3 of every orbit. Now, when you're down on that planet and you have, there's barely an atmosphere on Mars, it's a much better position to be slightly protected than not protected at all. So speaking of miles of rock, we are now going to go to the moons that are past the asteroid belt. And the asteroid belt is between Mars and Jupiter. And so we are going to the Jovian moons, or moons of the gas planets. So we're going to start with one of Jupiter's moons, Io. So Io is Galilean moon number 1. So Galilean moons are the 4 largest moons of Jupiter, discovered by Galileo in the 17th century. So Io is the moon with the most volcanic activity of any body in the solar system. So not Earth, not Mars. It has the most volcanic activity. And it's pretty interesting why this is caused. This phenomena is caused by the powerful gravity of Jupiter. Because remember, Jupiter is massive. It was actually supposed to be a binary star with our sun, but there wasn't enough hydrogen in our planetary nebula. So the volcanic activity of Io is caused by the powerful gravity of Jupiter and the lesser and smaller, but precisely timed pulls from 2 neighboring moons of Jupiter, Europa and Ganymede. So these moons, the other 2 moons of the 4, perturb Io's surface to such an extent that it causes the solid ground to move like tides. Now on Earth, we have tides as well, but with ocean water. The tidal forces pull the surface of Io to heights of 330 feet. Now, to contrast, tidal forces cause tides up to 60 feet on Earth. This movement of the surface, this perturbation of Io causes volcanic activity because it not only shifts the surface, but shifts the center of the planet as well. This causes friction, it heats up, and it causes this volcanic activity. Like Sarah said earlier, so now to talk about, beside the activity on it, what it looks like. So, Io is sometimes called the pizza moon because of its appearance due to its aggressive volcanic activity, it being geologically active, and its sparse craters. Now, Sarah said earlier that the density of craters is dependent on the age of the moon, but it is unexpected that Io does not have as many craters as it should, but this could be for a lot of reasons, including the volcanic activity that was aforementioned. So I think the next one would be Europa, which is Galilean moon 2. So Europa is actually one of my favorite Jovian moons because scientists have found strong evidence that beneath the ice crust on the surface of Europa is an ocean of liquid water or slushy ice. So in 1979, when NASA's Voyager missions passed through the outer planets, it provided the first insights into the possibility of a subsurface ocean. Now, ground-based telescopes on Earth, along with the Galileo spacecraft and space telescopes and Voyager, have increased scientists' confidence for a European ocean. Now, Europa has a water ice crust that is 10 to 15 miles thick. And, if you were to break down that crust of ice, you have dense, cold surface ice, you have warmer ice, and then you have, liquid or slushy ocean beneath it. So that crust is 10 to 15 miles thick. And beneath that is a 40 to 100 mile depth ocean beneath it. So how did we know that there was an ocean? How do we suspect there's an ocean beneath it? So as Voyager, as other telescopes, as the Galileo spacecraft observed Europa, they noticed plumes, and these plumes are caused by these plumes of ocean water are caused by tidal flexing. So tidal flexing causes plumes of ocean water to appear on the surface of Europa. Tidal flexing is caused when an object in an elliptical orbit, so this is a circular orbit, it's the shape of a circle, and elliptical is when that circle is extended, all right? So it kind of looks like, a canoe, and that's a really bad metaphor for that. Anyways, tidal flexing is caused when an object in an elliptical orbit has tidal forces acting on it that are stronger near the parent planet than farther away from it. So this is important because as Europa flexes due to the gravity of Jupiter, ocean water might seep into the uppermost portion of the rocky layer. So not only does it have a 10 to 15 mile crust on it, but it has this 40 to 100 mile depth ocean beneath it. Then it has a rocky layer, and then it has its core. So its core is not molten like Earth. So as the tidal flexing causes the everything to move and shift, ocean water might seep into the uppermost portions of the rocky layer to be heated and interact chemically with the rock. Now, this will cause the water around it to be loaded up with minerals and organic carbon-containing compounds as it flows back into the ocean through cracks or fissures. Now, Earth has similar features. We refer to them as thermal vents. So where this hot, rich, nutrient-rich water and rocky compounds are found, they're called thermal vents. So these vents are deep in our oceans, but are abundant with life. Now, this was something unexpected when we found them on Earth. Creatures without light thriving in large numbers. How? And this is because of the presence of heat and nutrient-rich minerals. And this is why Europa is considered to be a potential for life in this solar system. Now, I guess we are going back to Sarah, and she'll be introducing the rest of the Galilean moons.
All right, so the next Galilean moon that I will talk about is Ganymede. So it is the third Galilean moon. And Ganymede is kind of special because it is actually the most massive moon in the entire solar system. So from Mercury out to Neptune, there is no moon that is larger than Ganymede. And in addition to being large, it has a number of very interesting characteristics. So it has a thin oxygen atmosphere. And anytime we see an atmosphere that is present on a moon, even a tenuous one, such as the one on Ganymede, that's kind of exciting. Because atmospheres are unique. They are what allow us to live and thrive on Earth. And they are what allow certain, heating functions such as the greenhouse effect to occur to warm up certain regions that might otherwise be unwarmable. So even a tenuous atmosphere is very interesting. And this atmosphere is primarily comprised of monatomic oxygen, so just O, diatomic oxygen, O2, and perhaps even ozone, O3. So in addition to its atmosphere, Ganymede is also covered in sort of two types of regions. So it's covered in regions that are cratered, heavily cratered with those impacts that we've been talking about. And as we know, for the most part, these regions are a little bit older. And Ganymede is also covered in these sort of younger, more grooved regions. And these two things look very different, right? Grooves are not the same things as craters. And sort of the reason why Ganymede looks this way, why there are both these grooved regions and these cratered regions, and specifically what causes these grooved regions, is actually an unsolved problem in planetary science, arguably one of the biggest unsolved planetary science problems in our solar system. And it's very strange, and nobody knows what's causing it. And that is both sort of a hard spot for science to be in, but it's also very exciting because it means that we will be able to explore it more and hopefully answer that question with further probes, further science missions, etc. So similar to Europa, Ganymede also actually has strong evidence for a subsurface ocean. And it's obviously qualitatively quite different than Europa. You know, the outside is a little bit more rocky than it is icy, and you don't have as dramatic of a resurfacing effect like Europa does with those cracks, and we don't really see those sort of plumes like we do with Europa. However, we do see that there is some tectonic activity. You know, there are things are moving gravitationally in the moon itself. And with tectonic activity and with gravity, as Christina was saying, comes those thermal vents. And with those thermal vents come the possibility for life. So once again, we see that Ganymede may be a potential host for life in the solar system. There are some numerous reasons why Ganymede might not quite be as promising as Europa. I think the conversation around the type of ocean is a little bit more complex and not quite as directly supporting life that we see on Earth being there, but nonetheless, a subsurface ocean on a moon that orbits Jupiter. That's pretty cool, and definitely to both explore potentially what the subsurface ocean is like, and to identify or try to solve that planetary science problem of the grooved regions. Both of those things together make Ganymede a very interesting source for future exploration. All right, so wrapping up the Jupiter moons. So as we said at the beginning of this conversation, there are way more moons in the solar system than we have time to explore, and Jupiter is a prime example of this. So I think Jupiter has, I want to say 79 total moons. It's between 70 and 80. And that number actually does kind of fluctuate a little bit depending on named moons and confirmed moons, because some of those moons can be extremely small. So for the purposes of this conversation, we are not going to talk about those other 75 moons. We're just going to stick to these Galilean 4. So wrapping up Jupiter and Jupiter's moons now is Callisto. So Callisto is the fourth Galilean moon. It is the third largest moon in the entire solar system. So smaller than Ganymede, but bigger than many others. And Callisto is very interesting for a couple of reasons. First of all, as you can kind of see in the picture, Callisto has a very high albedo or reflectivity. So lots of the light that impacts Callisto is just reflected right back off, and it gives Callisto this qualitatively shimmery mirror-like appearance, which makes it quite beautiful. In addition to its high albedo, it's also very heavily cratered. So the surface is pretty much saturated with craters. And that means two things. One, it means that it's very old, as we've talked about. And two, it also means that there is very little resurfacing going on this moon. It's not like Europa. It's not like some of those other moons that have those active tectonic resurfacing events that reshape the surface of the moon. And it's sort of said colloquially that any new crater that hits the moon will just cover up an old one, because the moon is literally just that saturated. And these things together suggest that Callisto is actually pretty old, I've said that it was old, but it's tectonically dead, we like to say. There just really isn't a lot of exciting sort of internal agitation going on in this moon as there are in others. Nonetheless, there is likely a subsurface ocean present on Callisto as well, although similar to Ganymede, it is less favorable for life than Europa. And another fun fact about Callisto is that it is actually one of the moons of Jupiter that receives the lowest amount of radiation. So that could potentially make it similar to the moon, as we were talking about earlier, Earth's moon, a base for future Jovian exploration or potentially exploration into systems that are farther out. So out to the Saturn systems or Uranus or Neptune. So kind of interesting for that reason as well. All right, and from here, we will go ahead to beyond the asteroid belt and into Saturn. So I'll pass it over to Christina.
I need the next slide. Thank you. All right, so one of Saturn's moons, Titan. Titan is a moon of onlys. Titan is a massive moon, second only to Jupiter's Ganymede and larger than Mercury. This is a moon larger than a planet. Acknowledge that. It is the only other body in the solar system with surface liquids and the only moon with a dense atmosphere, standing bodies of liquid like rivers, lakes of methane, and seas. It is the only other body in the solar system to have Earth-like liquid raining cycles akin to Earth's water cycles. Now, note that I said liquid raining cycles, not water cycles, because it doesn't rain water. The surface of Titan is one of the most Earth-like places in our discussion of moons and in the solar system, albeit at vastly colder temperatures and different chemical makeups. The surface of Titan is one of the most interesting places. There is believed to be volcanic activity on Titan, but with liquid water lava instead of molten rock. Titan's surface is filled by flowing methane and ethane. This sculpts the rivers and lakes with liquid natural gases. Titan's surface has sand dunes made of hydrocarbons, complex hydrocarbons, grains, and appear like deserts, like Namibia in Africa. But due to its few craters, it is believed to be a younger moon, although it is possible that planetary processes have erased these features. Now, the atmosphere of Titan is significant. It's primarily nitrogen, kind of like Earth, hydrogen and methane with other trace gases. It has a greenhouse effect on it. It's warmer than other moons, which is promising. It's geologically active, like I mentioned, with volcanic activity, and it's analog to primordial Earth. It tells us a lot about what Earth could have been like at the beginning stages of life developing. And so now we'll go back to Sarah.
All right, so Saturn also has another very interesting moon, and that moon is Enceladus, that is featured here. And I'm just going to go back 2 slides to this image here, which compares sort of some of the sizes of Saturn's moons. And as we see here, this is Titan. It's huge. As Christina said, it's literally bigger than Mercury, so it's bigger than a planet. Whereas over here, we have tiny little Enceladus. And even though it's tiny, Enceladus is actually an extremely interesting source of study. So we will go ahead and talk a little bit about that now. So it is the 6th largest moon of Saturn, and it is actually 1/10 the size of Titan, so very, very small. And similar to other planets like Callisto, it has a very high albedo, meaning that it reflects a lot of the incident light on it, which makes it colder. And the surface of Enceladus is also very fresh, very clean ice, similar to Europa. It doesn't have a ton of those, crater marks. You can obviously, see some of them up here. But for the most part, this is a very, smooth, clean surface, which again suggests that there is a lot of active gravitational tidal effects going on this moon. And from that, we know that Enceladus has a subsurface ocean of salt water. And we have analyzed this ocean a little bit, which is very interesting. And we know also, backing up a little bit to sort of the crack marks, these cracks are due to that tidal heating that Christina was talking about earlier, where that gravitational interplay sort of excites and it agitates the moon itself. So similar to Europa, Enceladus could also have those thermal vents, which, as we know, life prospers around on Earth. So Enceladus could be yet another location where life could be present in our solar system that is not on Earth, which is very exciting. So the Cassini mission, which ended back in 2017, it was an incredible mission. I highly recommend reading up about some of the things that Cassini discovered. It was actually able to perform a flyby, or more accurately, a fly-through of one of Enceladus's plumes. And from that fly-through, it was able to determine sort of the chemical composition of that subsurface ocean. And through that fly-through, the probe actually detected trace amounts of complex hydrocarbons, methane, propane, formaldehyde, particles and molecules that we don't see existing everywhere just on a daily basis. And this could potentially mean that the subsurface ocean of Enceladus is a lot more complicated and a lot more complex and full of secrets than we know. Which again suggests Enceladus is a very interesting place for future research and future study. So another kind of exciting thing about one of the plumes of Saturn's, or one of the plumes of Enceladus, is that the plumes have actually been discovered to be the source material for one of Saturn's rings. So we're all familiar with Saturn. It has those massive, beautiful rings that are around it. And it is literally the plumes from Enceladus's subsurface ocean that have created part of those rings, which I think is just incredible. And scientists were able to determine this because they were able to analyze from the Cassini fly-through the chemical composition of the plume and then compare it to that of the rings. And the chemical compositions were identical. And from that, we were able to say, these two things are a matchup. So Enceladus, very interesting moon, arguably my favorite in the solar system. And it's going to be interesting to see what other discoveries come out of it. All right, so moving on out now, I will hand it over to Christina.
Totally have to agree with Sarah. It is completely okay to have your favorite moons. Total bias in scientific research. We do what we want here. So I'll be going over Uranus's moons, and Uranus has a total of 27 small moons with low albedos. So the albedo of a moon is the proportion of the incident light or radiation that is reflected by a surface. They are composed mostly of rock and ice, and we know this by studying the light that is reflected off these planets. That's why having a low albedo makes Uranus's moon so hard to study, because we can tell the chemical compound of an object by its light. It's difficult to study these bodies due to their distance and size, and therefore are not often considered as a source for planetary science research. However, they are unique in their own diversity, in their grouping. The planet Uranus has 27 known moons, most of which weren't discovered until the space age. They range from Titania, which is 981 miles in diameter, to tiny Cupid, only 11 miles in diameter. So Miranda, the innermost and smallest of the 5 major satellites, has a surface unlike any other moon that's been seen. It has giant fault canyons as much as 12 times as deep as the Grand Canyon, terrace layers and surfaces that appear very old, and others that look much younger, which is very interesting. And I would expand on it, but we have limited time. Cordelia and Ophelia are shepherd moons that keep Uranus's thin outermost epsilon ring well defined. The moons of Uranus are unique in their names as well. They are not named after various mythologies like you see in Saturn or Jupiter or Europa. Jupiter's moons have funny names too, because I believe it is Io, or Europa, is the wife of Jupiter in Roman mythology and is sent to keep an eye on him. So the moon is keeping an eye on Jupiter. The moons of Uranus are unique in their names. They are not named after various mythologies, but for Shakespearean characters. They Some were discovered in the 18th century, and then obviously the rest of them that we know of today were discovered in during the space age. The Voyager 2 spacecraft visited the Uranian system in 1986 and tripled the number of known moons. Voyager 2 found an additional 10, ranging from 26 to 154 kilometers or 16 to 96 miles in diameter. We have Juliet, Puck, Cordelia, Ophelia, Bianca, Desdemona, Portia, Rosalind, Cressida, and Belinda. This region of Uranus is so crowded. The region where the moons lie is so crowded that astronomers don't yet understand how the little moons have managed to avoid crashing into each other. Astrophysicists believe that these inner moons may be shepherds to the thin rings of Uranus and may yet still be hiding more moons. Because Uranus is so far away, and because these moons are very small, not very reflective, it's hard to tell if there are more moons, if they're there, and if they're large enough to be moons, but that is a semi-false statement. Uranus's moons are very diverse. They are very interesting to study individually. And to quote Shakespeare from A Midsummer's Night's Dream, which some of these moons are named after, "Well shone moon, truly the moon shines with a good grace." And I'll take that to Sarah.
All right, so last but certainly not least, we'll be talking about Neptune's moon, Triton. Now, Neptune has more than one moon. I don't know the number off the top of my head, but Triton is by far the most interesting, both from my personal bias perspective and from a scientific perspective. So Triton is Neptune's largest moon, and it is actually the only moon in the entire solar system to have a retrograde orbit. So you may have heard about retrograde orbits sort of in your everyday conversations with planets being in retrograde and whatnot. But scientifically, what this means is that the orbit of Triton is in the opposite direction of the spin of Neptune. So if Neptune goes this way, that way, Triton goes the other way. And so you have sort of this conflict between the two orbit directions. And this is a very strange phenomenon. It's not something that we see anywhere else, as I said, in the solar system. And because of this, Triton is not thought to have formed alongside of Neptune or in Neptune's vicinity. It's actually thought to be a captured dwarf planet out from in the Kuiper Belt. And the Kuiper Belt is beyond Neptune. It's out sort of by Pluto. And so this dwarf planet, Triton, was sort of meandered its way in and eventually was in the right place at the right time to get captured by Neptune's gravitational orbit. In terms of interesting features, Triton has that same sort of young, resurfaced feature that we see in other moons like Europa and Enceladus. And it also has a tenuous atmosphere with trace hydrocarbons. So again, anytime we see an atmosphere, that's very interesting. And similar to Mars's moon, Triton will eventually hit the Roche limit. And once it does so, it will become, as Christina said, torn apart because it can no longer be gravitationally self-sufficient. It can no longer sustain itself with its own internal gravity and overcome the gravitational pull of Neptune. And when that happens, it will become a dramatic set of rings, very similar to in appearance qualitatively to what Saturn looks like. And so, in millions of years in the future, Neptune will certainly be a sight to behold as it reflects sort of that dead, dramatic moon. So that said, that is sort of the last thing that we have planned in our discussion of moons. So we will go ahead and say thank you everyone so much for tuning in. These events and conversations are not possible without viewers. So thank you. And we will go
Always
ahead
nice
and
to see you guys here. Really, it is.
Yes, yeah, absolutely. So we will go ahead and open up the floor to questions, and feel free to drop them in the YouTube chat box. And we will wait a couple minutes. I think there's a little bit of a delay with the stream. So take your time, type up your question. We'll be here for a little bit more to answer them.
May I answer this one, Sarah? So, we don't harvest the thermal energy that are in our thermal vents here because they're so far deep. Energy dissipates really quickly when it's meeting, really cold water with, the heat of these thermal vents. So it's not really possible to do so. Now, let's say now this is getting really hypothetical. There's very little science behind this. Let's say there were, people, beings, something living down there. They use that heat. These animals down there, like in our thermal vents, use this heat to, power their own bodily functions and maintain that. It's also used to produce, food and, continually these cycles of life there. So it can't exactly be harvested like for our society's purposes, but it can be, but it is used. It's not just standing there. Does that answer your question?
All right, I will go ahead and wait for that answer. We'll circle back to it if you have any follow-up questions, which are more than welcome. And in the meantime, I will answer the next question, which is what is classified as a moon? So does the planet have an effect on its orbit, or does the moon affect the planet? So there isn't actually sort of an agreed upon definition of what a moon is. But sort of generally, colloquially, I guess, a moon is thought of as just some sort of celestial body that is orbiting a planet. And from that necessarily comes a gravitational relationship, because two bodies that have mass have gravitational influence over each other and impact on one another. But there is no sort of upper or lower limit on that mass or on that gravitational impact to classify one object as a moon versus another. So it's more sort of classify with your heart in terms of moons more than anything else. And in terms of Titan, so answering your question about that, could Titan have some form of life because it has a greenhouse effect, maybe microorganisms? So this is a very complicated question, and it's one that scientists puzzle over regularly. And the answer is maybe, which is not very satisfying, I know. But basically, it's hard to say that life on Titan would look anything like life on Earth because the atmosphere is so different. I think the pressure on Titan is also very high, which, structurally in terms of like lattice work of solids, it's tough for complex organisms to form. And even microorganisms potentially, yes, but again, they would look very different because they would have to feed on energy that looks very different than they do on Earth. So very complicated question. Different scientists have different opinions on it as well. So it's sort of viewer's interpretation, I guess.
And to add to that, there have actually been studies done by, I don't know which mission, maybe Sarah knows, but on Venus, they've actually tried, maybe it was Venus, maybe it was Jupiter, I'm not sure, to study the atmosphere and see if there was a possible for basically like bacteria that could be existing in the atmosphere of Venus. And I believe astrobiologists, which is a thing, were studying the potential for there to be life, or life as we know it, in these pockets of gas in the atmosphere. You know what I'm referring to, Sarah?
I think it is Venus, yes.
Yeah. And then Tammy, I think you had a question about the organizing system to naming the moons. To naming anything in this solar system, because a lot of it was done pre-space age, was usually the whim of the discoverer. Sometimes they name it after themselves. I know that originally Phobos and Deimos were named after, I believe it was Phobos and Deimos, were named after the wife of the scientist who discovered them. And then were renamed later on. But let's say if we get into like deeper classifications like nebulas or galaxies or clusters, there is a classification system that I think it's based in like order of magnitude, but I'm not sure. Sarah might know more on that.
Yeah, so for moons, as Christina said, there really isn't a laid down class or organization system to naming them, aside from I think Uranus, which is pretty much exclusively based off of Shakespearean characters and characters from Alexander Pope's works. But yeah, that does change with other beyond extra solar objects and bodies. And it's based off of a lot of different things. That's a whole other presentation.
And just a note, since everybody's here is obviously interested in moons in some capacity or another, there is a actual, like, our moon is having a phenomena occurring this week. It's called the Beaver Moon. It is 600 years in the making, and it will be the longest lunar eclipse of the century. And it'll be occurring on November 19th. NASA and space.com have released articles about it. And it'll be able to be seen all across North America exceptionally well. So if you're in Florida, go all the way up to the Everglades and take a gander at it. If you're in Minnesota, go north, go south. Try to get to a dark place where you can see it clearly without a lot of light pollution. Any more questions, anybody? And yes, Tony, astrobiologist is a thing. It is a growing field, astrobiology, as our technology develops and as we are able to get more in-depth details about the details of our planet, of our solar system. Also, one more comment on, as people put in more questions, we have a few more minutes, about classifying as a moon. Does the planet have an effect on its orbit, or does the moon affect the planet? I know Sarah answered this, but there was something I did want to add to it. Which moon was it, Sarah, that was believed to be a captured dwarf planet?
Triton.
Triton, yes. So to classify a planet, it has to clear its orbit. It has to be, I forgot, clear its orbit. Sarah.
Yeah, I mean, even the definition of what a planet is something that changes. I think it has to, yes, be gravitationally sufficient by the time its orbit is cleared. Yes. I think there are two other things as well. Let me just look this up. So what? So you're having a back row sneak peek into preparation for this. So what classifies a planet as a planet? Sufficient mass to assume hydrostatic equilibrium, and it has cleared the neighborhood around its orbit, and it is in orbit around the sun. So those three things.
Okay, and what it means by hydrostatic equilibrium is mean that it's as spherical as possible. Yes. Even like when they've taken, when they've analyzed our moon, our Earth, our planet, they have seen that even the Earth isn't entirely uniform. It's not the perfect sphere. Very few things in our universe are perfect, or perfectly sphere, perfectly straight, perfectly linear. So what classifies as a moon is even more nondescript. So you can kind of think of it hand in hand, that classifying a planet, classifying a moon is a difficult thing because of the diversity of bodies in our solar system. That's something to consider, because there's always been that argument about Pluto, about whether it's a dwarf planet, whether it's a planet. It's not a planet at all, because there are moons bigger than it, and there are, small, and there are moons smaller than it. What are you going to consider a planet? What are you going to consider a moon? And there's one more question. Is there any more info about Enceladus and Saturn's rings? I think that's really interesting.
Yeah, so we can just give a few more little fun facts about it, I guess. So the E ring, which is the ring that the Enceladus plumes contribute to, it's the outermost ring of Saturn. It's the widest as well, and it is very wide but very diffuse. And there's actually like lots of like microscopic ice and dust and material that is distributed sort of between the orbits of Mimas and Titan also, that is part of those rings. So kind of interesting. I know the rings are also like unstable, and their lifespan is between like 10,000 and a million years or so. And so like the particles must sort of constantly be replenished, which makes sense because the sort of the plumes themselves are constantly sort of outpouring material into the ring. And there's lots of other interesting things about the rings themselves, chemical composition and whatnot, and what that means in terms of the age of the rings and the source of it, Enceladus itself. But I definitely encourage doing more reading about that, because I agree, it is very, very interesting.
And you can find more information about all these moons, including interactive pictures and videos, and even like quizzes, games on NASA's website. If you go to the NASA Solar System Exploration and then you just Google that, it'll show you info about Enceladus, Ganymede, Europa, Io, all of them. It'll be much more expansive than what we have done in an hour.
All right. We're almost at time, so last call for questions. Yep. Thank you. Thank you guys again for being here. Really appreciate it.
Really appreciate it. And if you have any more topics that you're interested in, please feel free to check in on the next Universe at Home, and look at the past videos. They're all uploaded here too. Sarah has more information on future presentations.
Thank you. Appreciate you being here.
Thank you.
All right. Well, with that, I think we will go ahead and sign off. So have a wonderful evening, stay warm, and we will see you next time.
Have a great night, everybody.
Whew.